Hi, everyone. This is Carlos Pazos with SparkCognition, Product Marketing Manager for Automated Model Building and also Natural Language Processing Technologies. I'm here in the room with another of our experts, Kit Moore. He's Product Manager for Automated Model Building. And we're going to start with the seminar. Before we jump straight into the topic, I would like to remind you that we have the chat option. So any of the questions that you have regarding the topic, please go ahead and post your questions there. We have Kit actively working there to give you answers. And also at the end of the presentation, and we're gonna have a demonstration, we will open it up for the panel. We're gonna reply to your questions directly. So with that, let's start with the topic, essentially this panel of automated model building. And the reason behind doing this is because automated model building is something that we use every day here at SparkCognition. Many of our technologies and solutions that we have for predictive maintenance, that we have for natural language processing, for security, many of our solutions and products, they use these technologies. And we realized that it provides a lot of value in terms of targeting specific aspects of the data science process, and it truly accelerates the creation of machine learning models. And that's exactly what we would like to share with you in this seminar. So I'm going to start with this concept that it should not be surprising. The fact that we are drowning in our own data. For some industries, that's true. For other industries, the quality and amount of data sets is a little bit limited. But the reality is like, okay, we have all this data, and what can we do about it? All of us here in this seminar, we have an interest in artificial intelligence, in machine learning, and what that can do about this problem, right? Because in many cases, it's a very good approach. And I would like to present you with this opportunity for different industries. I know that in the audience we have people from with different backgrounds, coming from different industries, on the different kind of applications that can actually be targeted for each of these verticals. So think of how we can make operations more efficient. How can predict outcomes in our business? How can we automate workflows? How can we enhance the decision-making process in each of our industries, right? And for all these challenges and applications, the use of technologies that accelerate those processes to provide these insights and outcomes, that is going to be key, right? Now, something that is important to acknowledge, and going back a little bit at this concept that we have all this data, is that as these industries, they go through this process of digital transformation, and during the last decades, you have here all this industrial IoT, Industry 4.0, and digitization, etc. And we are adding sensors to our assets, and we are putting in place digital infrastructure, and we are doing, to some extent, analysis and visualization of that data. Well, how we can actually extract value of that, right, to actually deliver the promise of digital transformation. And that's what we like to refer here, SparkCognition, as digital activation. It's actually activating the data, and that means being able to provide predictions, being able to provide confidence in the decisions that we are making. And something that is extremely important is that it's not just a one-time scenario, but it's something that it's a continuous process, right? It's a process that improves and improves over time, and continues. It will continue delivering value, right? Now, something that it's in between these two areas, digitization and activation, it has to do a lot with how we approach the problem. Yes, there's enough data, but also let's take a look from the perspective of capabilities in terms of how we make sense of all that data and the tools that we are using for that. Out there in terms of digital technologies, there's a jungle of different options, right? And all these different options, they have to be comprehensive enough. They have to be easy to adopt and adapt and easy to integrate into our processes to be able to extract that value, right? Our approach here at SparkCognition is to focus on cognitive analytics to tackle that challenge, which is essentially the use of automated model building to accelerate the machine learning process. So with that, I would like to very quickly review this machine learning process for all of us to be on the same page and understand what aspects of the process we can tackle with automated model building. Here you have a very generalized view of the machine learning process, and in very general terms, what we do with all that data coming from sensors, coming from different data storage, etc. First, we need to prepare the data, right? We need to make sure that that data can be used for the process, and that has to do with making sure that the data is balanced, that we don't have missing data, that it has the right scales, etc. Once we have that data ready, well, we need to start looking for features on the data, essentially identifying, well, what's important about the data that actually will make a difference in my problem. And with that, we start creating an architecture, right, of a model, essentially describing the outputs of those important features. And being able to create something that is optimized, being able to create something that has the level of sophistication that many industries require, that's a challenge, because this is an optimization algorithm, this is an optimization process, and it takes time. And effort to do so. Now, there are very special people in the industry, data scientists, that are very familiar with this process, and this is what they do every day. They go through all this data, they extract the features, they understand the problem, and they create these models. They are, if you will, the unicorns in the industry, because they have the required level of expertise and experience to do all this process. However, when it comes to adopting these technologies, there are barriers, because data scientists, they're in high demand. And even companies that count with data scientists, potentially they don't have enough data scientists to tackle all the challenges that they have. So yes, that's an expertise that is required. Second, as I was mentioning, being able to achieve the accuracy in those models in a limited amount of time, that's another challenge, because this is a time-consuming process. And finally, the tools out there that are being used to go through this process are not necessarily impacting productivity yet, right? So with that in mind, here in SparkCognition, we create artificial intelligence solutions for many verticals. And I'm going to touch on some of them during this presentation. But again, something that we do every day is to create these models. And we use the automated model building process to power our solutions. We decided, like, okay, so if this is something that we're doing every day and has a lot of value, a commitment that we have as a company is to also contribute to the artificial intelligence society with tools that advance this science. And we decided to productize this process with a solution called Darwin. Essentially, Darwin, what we have done here is package this automated model building process with the intention of give the ability to subject matter experts and data scientists alike to generate these machine learning models in a very accelerated fashion. It gives the ability in a mechanical way, because you're putting this solution to work through all this data, and being able to extract all the different features and go through all this process to create highly accurate models, right? And something that is important is that when it comes to Darwin, it's not, and the automated model building process, it's not just about creating the models, but also giving the ability to maintain these models, being able to scale operations by creating all these solutions in a very accelerated fashion. And finally, for those companies or organizations that lack the experience of data scientists, this is something that can truly bring value to the organization and can accelerate the creation of data science projects. So when it comes to this technology, what I would like to focus here, aside from that, yes, the technology is available, we have put it out there in the market, I would like to focus on the approach that we have, which is essentially a combination of evolutionary algorithms and backpropagation optimizations. And for those that don't have a data science background, we're gonna go into more detail on how this works. But think of this automated solution that can take your data and can generate as an output models to solve problems in the supervised and unsupervised realms. So the way it works is like, if we are to generalize it a little bit, this is the section of the data science process that Darwin can actually accelerate. It's important to acknowledge that before coming to this specific point of the process, a data scientist or someone in charge of the data already prepared the data. And here for Darwin, what we receive as an input are rectangular data sets. And that's what Darwin is going to be able to ingest. Now, once we have that rectangular data set, Darwin is going to automate these steps. Darwin is going to take that and going to implement pre-processing. That means that all the part of scaling, if we have data missing, Darwin is going to select the right imputation method. And it's going to make sure that the data is balanced so it can be used for the process. Once that's done, Darwin is going to start the feature engineering process. So that means that for each of the characteristics that we have in our data set, automatically will generate dozens of features in the time and frequency domains. And then it's going to select from those features the ones that are more representative. Now, the final part of this process is actually creating the model. And this is the trickiest part, because this is the optimization part. When it comes to the IP that we provide and how this technology is approaching automated model building, Darwin here will create hundreds of architectures for the model based on those features, and we'll test them. We'll select the best architectures out of that, and we create a new generation going through all this process again to just like keep the best architectures. Darwin will do this in a very mechanical way over and over again, multiple generations, till it's capable of reaching a certain level of accuracy, or has reached the time limits that we have specified for training that model. Now, with this process in mind, it's quite beneficial either for a data scientist to be able to go through these specific steps and automate this section, or for someone that is not that familiar with the process to be able to generate model buildings, to generate machine learning models with a very, very decent level of accuracy and in a very accelerated fashion. Now, this is the concept, but I would like to show you an actual demonstration of how this works. I'm going to jump to this side of the screen, which is a Jupyter notebook. And what I'm going to be showing here is one of the things that we have made available to our users and the community, which is the Darwin SDK. Now, this is one of the examples that comes with the SDK. And in this example, we are going to create a model for a supervised problem. As you can see, it's fully documented. Here are some libraries that come directly from Python. I'm not gonna go into the detail of these, but I'm gonna show you in this section how we are actually calling the Darwin SDK. Now, this is interesting because now I have imported the Darwin SDK into the actual Python environment. Now, how does this work? Well, now that I have that, I have to connect to a server. And this is what I'm highlighting here. This is the trial server. And here I'm gonna make a plug that all that you're observing here is available for trial. So you can use it, you can experiment it. And once you're part of the trial, you can connect to this server. And with your username and password, you can start using this. Okay, well, now let's take a look at the problem. Okay, so I'm gonna load here in Python my data set. And this is a very particular scenario. Remember, we are doing a supervised example. We are doing a time series, and we would like to make a prediction on this time series. So it is a regression problem. Now, what we're observing here in this data set, I'm just showing the first 5 rows, but this is a data set that has 3,000 rows and 33 columns. And it has to do with the real estate situation in Boston. So truly what we're showing here is different properties. And as you can see, all the different features for those properties. Think about the lot area, the living area, the type of roof, exterior finish, etc. And what is interesting about this data set is that based on all these characteristics, we would like to predict what is the value of that property. What is going to be the valuation of that property? All right, so that's going to be our target for our supervised problem. Perfect. So I'm going to upload my data set, and now I'm going to create the model, and I'm going to run this instruction. And I would like to highlight this method that I'm using in the SDK, which is essentially create model, and this is essentially the automated model building part that Darwin is doing. Now, this method, what it requires is first a data set, right? What is the name of your data set? And that's something that we have done already. Second, I have to specify what is the target of my data set. Now, something that is very cool about Darwin is that if I specify a target, it's gonna train this model as a supervised learning problem. If I don't specify a target, that means that I want to learn from my data, and then I'm dealing with an unsupervised problem, right? That's another possibility. Right now, we are focusing on the supervised problem. I specify the name of my model, and finally, what is the maximum training time for that model? And those are the parameters that I have to give to Darwin. In this case, I'm specifying just 1 minute. Okay, so here you see that Darwin right now, it's hard work. And as you can see, I'm going to highlight some important aspects of this. First, the percentage that has completed. Here you have 20%. Right now it's going around 60%, but it's giving me the percentage of completion of this process of building the model, right? And also something that is important is that it's also giving me the actual loss of the model. Now, this value is important for data scientists. As you can imagine, the smaller the value, the better. And as you can see, as we are progressing in our iterations, Darwin is actually gonna reduce that loss, right? And that's a measure of how good my model is in terms of predicting the values of my problem. Now, the other thing that Darwin is doing is creating these generations. And that's something that I would like to emphasize here. There you have, in this case, the number of generations. And what does this mean? We mentioned that Darwin in the background, with this instruction, what was happening is that ingested the rectangular data set, all those columns and all those different characteristics that we have for the problem, went through all the data cleaning process part of it, generated all those features. Remember, dozens of features in the time and frequency domains, and also started creating architectures. Okay, so those architectures, Darwin selected the best ones and kept that for the next generation. And as you can see, as we are progressing here, it increases the number of generations. And actually, my job already is completed. So we are 100%. We see that the loss, it's actually now smaller. And we ended up with 3 generations. This is very important because we are actually exposing very valuable data on how this model is being created. And I'm gonna give you some examples of that. Of course, we have the option to increase the training time. We know that in order to increase that accuracy, I have 2 options. Either I provide more examples or I train this for a longer time. This for demonstration, it was just a short training time. But something that is important here is that I can actually analyze my model. Darwin is not a black box. Darwin allows you to truly explore everything that happened inside of the data science process and inside of this process of actually building the project, right? Actually building this model. So something that I can do is call this method analyze model, and will start giving me important information. It's returning again the number of generations, the loss, etc. But something that I also have here is the feature importance. Now, when it comes to feature importance, I think it's a fantastic way of learning more about your problem. Here we are taking a look at what features actually have an impact in my problem. In this case, for the Boston scenario of properties, in order to specify the value of a property, these 3 aspects, these 3 characteristics, they have a real impact, right? And I can start learning more about my problem. But now what I would like to do, and the whole purpose of creating a machine learning model, is to make predictions. So the first thing that I'm gonna do here is to actually run that model on the server. If you remember, when we started the demonstration, we connected to the server that we're using to run Darwin. I would like to make the point here that in terms of Darwin, and it's the same for any other solutions for SparkCognition, these solutions can run on the cloud, can run on premises. So you can imagine that you can have this on a server on premises and start sending jobs to this server to create your models. Another option that we have to interact with this is that we have a REST API. So we can actually make REST calls and being able to access to all this information. So here I have an example of that. Imagine that I make a REST call, or in this case, I'm using the SDK, and I'm getting the prediction for the first 5 properties. This is the expected valuation for those properties, right? And I can feed new data to this model and get new estimates, depending on all the characteristics of those properties. Something that is important is like, okay, that's good, but how accurate that is? Well, we were talking about the loss, but here's another way of looking at it. In terms of regression problems, we report that with this R-squared scoring. And there you can see how close the model is to the actual data set that we use. I would like to remind you that in this demonstration, it was just 1 minute of training, and everything we did was feed that rectangular data set, and as an output, we got that model. And this is showing us how accurate that model is in just 1 minute of training it.
One thing to call out about this as well, and this is Keith Moore, the product manager for Darwin, is that what you're seeing in this plot is The x-axis is going to be the actual value of that home, and the y-axis is going to be what we predicted as that value for that home. And so in an ideal perfect model, it would be a one-to-one relationship for every value, meaning a perfectly straight line. You can see in what we're showing here, there is some variance, but it is very minimal. And that generally we predicted very closely to what the actual value of those particular homes were.
Thank you, Keith. Finally, when it comes to what we can do with Darwin, and going back to this concept that Darwin is not a black box, we can explore how the architecture of the model was created. It's actually showing us there the different layers of the deep neural network. Darwin is telling you, hey, this is the method that I use. I created this network, and this is the number of nodes that we have on the outer layer. The output is obviously 1 because we are just predicting one value, but also all the intermediate layers. Now, this is something that data scientists do, and they test and try different architectures, but Darwin is already giving you this information. Again, it's not just creating a model and here you have your prediction. It's giving you access to all the different aspects that that you need to consider when creating those models. All right. So with that, we're gonna go back to our presentation, and maybe one question that that you're asking yourselves at this point, like, all right, so I have access to this automated model building tool, but truly how accurate this is? Well, we took that task and actually went through the exercise, and we created this report for our customers and people interested in this. It's called the Darwin Efficacy Report. It's available online. This is just a snapshot of this. And essentially what we did is that we took Darwin and also a series of open source machine learning solutions as well. And we put all of them to the test of creating models using different scenarios. So time series problems, classification problems, and all of them, we allow them to train the model for 20 minutes. All this data was generated synthetically. So all of them work under the same conditions. And there's a reference, you see the data set that we were using, the Boston housing regression. But also you see other data sets here, like from Kaggle, for instance. You can see that for very well-known problems, the performance is very similar. But truly when Darwin makes a difference is when you're dealing with problems that are highly complex, that they're not very well known, and also for time series, when you need to create models that need to remember long data sets. And you can see the results on the left side of the screen, how Darwin performed against other open source solutions. So this is something, again, this report is available online. If you're interested in looking into more detail on how the test was implemented, the data sets that we use, and the methodology, I will invite you to take a look at this report and see the results. But to this point, we have seen some examples of how Darwin can help and accelerate the data science process. But something that is very important here in SparkCognition is the actual real implementation of this technology. And I was mentioning at the beginning of the seminar, this is our mission, that to actually bring this to real scenarios, right? And I would like to show you a series of quick case studies, examples where we have used automated model building and these technologies to provide value back to companies and back to organizations. The first scenario that I want to touch, it comes from the oil and gas industry. This is a scenario for back office optimization. So even just for oil and gas, it could apply to other verticals. Think of finance, think of healthcare, etc. Because in this case, the problem was to automate the process of how to redirect support tickets to the right groups in the company. So essentially, what we did is like, okay, we need to automate this process. Let's take those support tickets and actually vectorize the keywords on those support tickets to create a classification model. So essentially, we were dealing with 24 different classes, and we created this model. Now, what is interesting about this problem is that as a very first approximation, which is what we're showing here, we trained this model for about 35 minutes using the technology that you just saw. And we were able to reroute those tickets to the right groups in over 75% of the scenarios, right? So this talks about how this technology first allows you to create models in a very fast manner, but also the level of accuracy that can be achieved with this first test. So this is one nice example of backpropagation optimization. Again, this was for an oil and gas company. And moving a little bit more outside from the office, more upstream for production and exploration, this is another problem that we approach with the same technology. This is something that exploration and production companies deal with all the time, and it's a big problem, which is essentially knowing the state of drill heads when they're operating. And what we created here was machine learning models to be able to identify those states. So what we used to approach this problem was time series snapshots of data coming from the sensors of the downhole drilling process. So we took that and we labeled that as possibly 17 different known drill states. And we approached this also as a classification problem. So as a result, we were able to perfectly differentiate between all those different operating modes of the drilling head. Now, this is a game changer for the industry because it truly provides operators with valuable information of how the rig is performing, and being able to compare that against these key performance indicators and do this in real time, right? So this is feeding data in real time to these models. Now, moving to a different industry. This is another example of how automated model building has helped our customers. This is an example for the aerospace industry for inventory management. This is more about like predicting like when I'm gonna need parts replacements for aircrafts. This example is very interesting because truly, when it comes to the data sets, we had snapshots. This is what I was mentioning at the beginning, that in some industry data sets are limited. They're not that big, and still this approach to automated model building can provide great results. So in this specific example, we were trying to identify degradation on supplemental cooling units. And essentially, we treat this as a binary classification problem with Darwin. Just as an anecdote to this problem, when we received the data set, this was trained for about 10-15 minutes, and we were able to successfully predict 86% of degradation of these components in the blind testing. Now, when it comes to the value to the actual user, is the ability to add this prediction to their value chain, the ability to do better planning and actually mitigate all these hidden costs that they were having in their maintenance solutions. So that's another example in a different industry. Moving to another totally different industry, more for now in the finance sector. This is something that it's very important to be able to identify fraud in credit cards transactions. We help this financial institution to predict fraudulent transactions in credit cards. Essentially, for the data use, it was coming from the customer accounts, the balance information, the amount of the transaction, but also the transaction type. Again, we implemented Darwin to provide this, and this is a more known problem. Truly here the performance was nearly perfect, nearly 100%. But the value here is to reduce the false positives, being able to make these systems more robust. So this is another example of how those models are helping. And finally, for a totally different industry, I would like to show this example from the manufacturing world, where we have people, essentially process engineers, looking for defects, impurities in minerals. And in this case, we use machine learning to create models to ingest data from the physical characteristics of these minerals. Think of the pH levels, densities, and other aspects of the manufacturing process. And in this case, was a time series. And we successfully created models that were able to identify 90% of these impurities. This is a huge time saving for these process engineers, because they don't have to be there in the lab hours identifying these same things, when you can have models that were created super fast and provide this level of accuracy that can solve that problem. So there you have a series of examples of the things that we have done in different industries with our automated model building approach. And finally, to close this section of the webinar, I would like to invite you to participate in the trial. Truly, this is something that we are making available to our customers. Is the technology behind other our solutions that we use on a regular basis. Try Darwin, give it a try. Upload your data set, check the level of performance, and see how it can actually automate your workflows when you're creating data science solutions. So if you go to SparkCognition.com/Darwin trial, there you can get access to pretty much everything that we have covered in this seminar. Now, with that, for the rest of the time that we have, it's about 20 minutes, I would like to encourage you to go to the chat. Again, we have Keith with us here, and ask all your hard questions about the tool, about other solutions, applicability, etc. So I would like to open at this point the forum for questions.
As people are starting to document these questions, there were a few that came in prior to the session that I will go ahead and try to address. So there was one of the first questions we got, and we got it from multiple individuals, is in automated model building in the whole AutoML space, do you value interpretability of models? And as Carlos showed in the example, that is absolutely something that we care about with Darwin. One of the few, I would say, one of the few items that's always of critical importance to us is being able to present something that is not only valuable, but also defensible. One of the biggest hurdles we face in the machine learning space is models that cannot be explained, but are valuable. And so getting to that point of implementation where the rubber meets the road is very challenging. So within Darwin, we actually have two different levels of interpretability, as well as something else that is a third that enables users to be comfortable with what they're receiving. The two different levels of interpretability is on a per model basis. We will actually give you what is important about those models, as Carlos displayed, what features are driving the decisions made by that model. And when I say features, what variables impact the decisions or results of the model. But we also, a second thing that we've done is on a per prediction basis, there is actually a function call within Darwin that enables you to see exactly what drove a particular prediction. So in the example that was shown in housing, it showed that house size was the #1 driver of price, but there may be a house that is a little bit smaller in a very expensive zip code. And so how do you account for that? And so what Darwin will actually do is it will look at that individual house and tell you house size wasn't what drove this price up. Zip code was the #1 driver for this particular house. And so you're able to, on a per prediction basis, provide something that is interpretable to a user and valuable. And the final thing that we do is we will always try to output exactly what is going on under the hood. So we're not trying to say we have a black box model that you can never see or never have access to. And we will actually show all of that to where if you want to go and reproduce it on your own, that is something that we can absolutely do.
Perfect. Thank you very much, Keith. We have several questions about the content of the seminar. Definitely, this is going to be available, the video, the recording, everything on our webpage. We're going to make sure that you have all that information. Now, we have other questions here, like, hey, how do you know if you have selected the right data and that it has been cleansed enough?
That's a great question. I will take that one. So when it comes to the right data, and this is really one of the things that Darwin enables you to do, or really the automated model building space allows you to do, is that if you have presented the data to an automated model building tool like Darwin in the correct format, it will really quickly come to a conclusion on that data. So I hate to use, the Silicon Valley-esque overused term fail fast, but with automated model building tools, especially Darwin, you can be very confident that it is trying to produce the best model possible at any point in time. And given, we'll say 30 minutes of training, 1 hour of training with kind of a GPU unit behind the cluster, you can be confident, if you're not seeing a good level of accuracy, that the setup of the problem or the data that is presented in the problem is not adequate to solve the particular problem at hand. And the example I always like to go back to is if I try to predict what will happen to a stock based on the weather, I'm going to be disappointed 100 times out of 100. And so with a tool like this and with a product like this, you're able to really quickly get to that conclusion to try to modify what inputs you actually introduce to solve the problem more effectively.
All right, Kid. We also talk about how Darwin is not a black box and it's actually giving you more insights into what's going on. There's a question here. It's like, hey, is it possible to see into the algorithms that Darwin creates through all this automated process?
Yes, absolutely. So one of the things, as Carlos showed, is we will output exactly what model is used as it pertains to what algorithms are behind the hood. There are pieces of that are core SparkCognition IP. We actually have patents filed that you can actually look up on the USPTO as to how we use genetic algorithms to try to better find the appropriate model for a data set. But we also have a white paper that we've developed on our website that explains exactly what is going on behind the scenes. If it pertains to particular questions on what's happening in that algorithm at intricate levels of detail, absolutely reach out to us. It is something, as anybody who works here will tell you, I am happy to speak about for hours at a time. So would love to connect if that's of interest.
Absolutely. There's another question here about sharing the Darwin efficacy report. That's totally something that we can share. It's available on the web, but we're going to make sure to share with you as a follow-up of this seminar. Other of the questions here interesting is like, hey, when it comes to actual deployment, Kate, can you comment more a little bit more about how is actually Darwin working in terms of cloud versus premises?
Absolutely. So we started as a company about 5 years ago working in the energy space. And when I say energy space, that means oil and gas and utilities were the primary market that we focused on. And as a function of that, having the ability to deliver on-premises solutions is critical for us as a company, because a lot of times cloud is not an option, whether it be for security or bandwidth reasons. And so all of the products that we make here at SparkCognition are available in the cloud as well as on premises as needed. Now, getting into, with Darwin in particular, to be very tactical as to how we deliver and how we deploy, the model building aspect can live both on premises or in the cloud. But what about the model itself? What if I want to push this model to the edge? And so we actually give users the ability, not within our trial experience that Carlos showed, but to our enterprise customers, they have the ability to actually download the models and the whole pipeline that involves cleaning of data, feature elevation, handling of different types of variables, that whole pipeline along with the model, and embed that into their processes with no need for any API or SDK as a function of it. So that is absolutely something that we have worked on and thought about as well.
Perfect. So, Kit, you commented a little bit that there's an actual white paper that we can share that goes into more technical detail of what's behind Darwin and the algorithms. There's here a question about what kind of algorithms Darwin is using and how is Darwin actually selecting those algorithms?
Absolutely. So on the supervised side, algorithms used are going to be, there are three different algorithms, or we'll say fundamental algorithms that make up Darwin. The first is going to be random forest. I think when I first got into the field of data science, that was my favorite algorithm. I think it is generally good at a lot of things. So it is also part of our Darwin model building process. The second is going to be XGBoost, which is another tree-based variant model or a variant algorithm. And the third is neural networks. And so we actually use three different types of algorithms under the hood. We're always exploring new algorithms to add in. But what we have found is that with those three, for all of the different data sets that we play in, and particularly in the time series domain, in the area where we are trying to be impactful, we see very good results, and no models or no algorithms outperform what we have on a generation by generation basis.
Perfect. Thank you very much, Kit. There's a question here. It's like, hey, what happens in terms of next steps for Darwin development? What we show here in the seminar, we show the SDK for Python. Truly, when it comes to next steps, and I would like to invite you to be part of this trial, we're working on a configuration-based user interface to automate this even more, take it to the next level. And we're gonna have a beta of this user interface very soon. So if you are interested in participating in this beta, evaluate this user interface and provide feedback, definitely you're welcome to do so, and let us know if you wanna participate. All right. There's a question here. We pull data directly from SCADA and build models from this data using predictive analytics. Beyond the data selection, can this process be automated?
Absolutely. And so if you think about what that means, there are a lot of different pieces that go into, we'll say, pulling data from SCADA systems and getting to the model building process and deploying those models. But my background is actually, I was a engineer and then product manager at a company called National Instruments, where that was my world for the longest time. And if you think about what those pieces look like, you have, we'll say, a historian or OSI soft pi or some database at which all of the SCADA data is being stored. We can extract that data in an automated way, and there are a lot of different processes for doing that. Some of them we've built in-house, and there are a lot of tools on the market that enable that capability. You can automate the model building, whether it be on a batched or semi-continuous asynchronous basis, and redeploy those models in a complete automated fashion, no human intervention needed. Now, one of the things that I do recommend is having very robust quality assurance systems if you are end-to-end building that process out, because you never want to either have data challenges or we'll say corrupt data that influences the new model that is built and deployed without ensuring that it is going to continue to add business value to your organization.
So it seems like there's a general interest of how to integrate Darwin with existing tools, either cloud or SCADA, different data sources. Something that we have done is partner with Google. That's one proof point there, that Darwin is actually available in the Google Cloud platform. It shows the level of integration with other tools. But I don't know if you want to expand more on best practices, techniques, or
Absolutely.
what to expect of that.
Absolutely, and it all depends on what the business concerns are. So from a pure integration perspective, for model building, deployment, explainability, and all of the functionality within Darwin, it was built from the ground up with the expectation of being integrated into business processes and into other solutions. And so it is available for access via an API, an SDK, or software development kit, as Carlos displayed. And then the user interface piece will be for the model building. But when you're talking about integration to a solution, the API would be my recommended course of action, in that you can use it to be as flexible you want and automating just about any process, to where if you were to come to me and say, how do we automate end-to-end, pulling from a SCADA system all the way through to redeploying models on a nightly basis, we can do that. We want to talk about looking at support ticket triage and integrating with the actual ticketing system such that we are adequately sending the right support requests to the right organizations. That is another thing that can be done. And because an API is such a flexible mechanism for software development, there's a lot of different ways in which we can do it. And so I don't mean to answer this generally in that we would end up implementing this in a way that best fits your business if we were to do it at SparkCognition, but it's also something that teams within a particular organization can do with very minimal contact with the SparkCognition team if needed.
Perfect. And here's a tough question for you, Keith. Where you have seen failure of Darwin in the past?
Oh man.
And what we have done to actually address these limitations?
Yeah. Oh, this is a great question. And I am very much so of the product manager mindset, in that I would rather release a product to users and get candid feedback on real use cases than spend years and years trying to build something that may miss the market. And so we took that approach with Darwin. We had this tool that worked internally primarily for time series problems. And one of the first customers that came to us threw a problem at Darwin that was really, really small, and it had a lot of categorical inputs. And so this was a classification problem, and they came back and they said, hey, I noticed that Darwin doesn't do as well as random forest on this particular data set. Because the very first version of Darwin that we released, keep in mind where our challenges are as a company historically, Darwin was only neural network based. And so instead of saying, hey, well, we didn't design it to do that, it was, well, it seems like some of our customers would get value from being able to solve those problems as well. Are there ways we can introduce random forest, XGBoost, other model types or other algorithm types into the genetic process that enable us to better solve their problem? Now, I won't claim that we have some new variant of XGBoost or random forest that is going to be infinitely better than something a data scientist can put together. But I do know that if you are looking for a very good model that is optimized for a data set, the introduction of those algorithms to Darwin after release has been extremely valuable. And so that was, I would say, the very first use case of us having to grow the product to ensure that we were meeting the customer needs.
Perfect. I think we have covered most of the questions. I think the only one that is probably we have not answered yet is people were asking about how to evaluate the performance of the model. A little bit more of explanation behind the laws and what's happening in that process.
Yep.
If you can expand a little bit more on that.
Yeah, absolutely. And so this is subjective, and I will say that up front. How do you evaluate a model? Because if you think about using accuracy as the call out, and this is as a non-data scientist a long time ago, I used to think, well, I need to predict something. If I can predict 9 out of 10, I am 90% accurate, and that is pretty good, right? I'm used to the ABC American education system where 90% is something that is to be desired. But what if I were to take that same terminology and say, well, I am able to accurately predict whether or not a part will be needed for an aircraft 9 out of 10 times. But the twist is 9 out of 10 times, you don't need a part. And so my model has basically learned, let's say, to just predict that we never need a part, and it can still be 90% accurate. So instead, what I care about is I care about the recall of that model. I care about, of the times I need that part on the shelf for a particular aircraft, is my model able to give me that number and say 90% of the time, can I actually predict when it will be needed with a level of accuracy? And how many false positives am I willing to accept to do that? And so there are a variety of different ways to calculate really the error of the model. Now, the loss that Carlos was showing that is actually displayed during the Darwin training period, there are a variety of losses that exist within Darwin. And as a user, you can actually specify which one you care most about or what you would like to use. But what that is doing is essentially showing
for the neural network on data that it has never seen before, or for the random forest XGBoost on new data it has never seen before, how well is it performing based on whatever function is specified up front. Now, Darwin is going to, out of the box, try to find the most active or best one for a particular problem, but a user can always go and specify what that is. And so to make sure that I'm presenting that appropriately and really tying up this explanation is that if you think about what Darwin does, data science is a blend of art, which is how do I set up the data and how do I set up the problem, and math, which is how do I take the data and problem setup and most optimally find the best answer for that data and problem. The human and people are always going to be responsible for that art, because Darwin does not know how to join a bunch of databases together or what is relevant for predicting something. But where Darwin comes in is the math, and that it is going to try to find the best way of solving that problem such that the person can spend more time on the setup and understanding of lateral thinking and agile thinking to that problem, and we will take care of all of the iteration and exploration of the mathematical components.
So a final question here for you, Keith. There's interest in knowing, like, okay, Darwin is selecting a specific method to provide an answer. Will it be possible for Darwin to show a comparison of the performance of the multiple different methods?
Yes, that absolutely is something that we could present, and we have had certain power users ask for that, actually, which is, given n number of models, which methods are most effective, what approaches are most effective, and essentially show per generation, give me everything that was tried and give me the accuracy of everything. All of that happens under the hood, and so exposing it is something we do not do currently, but absolutely could given the need.
Perfect. All right, we have a couple of minutes left. I just would like to remind you that all these content of the webinar, the recording is going to be available for you guys. We're going to share the efficacy report if you're interested, and also if you're interested in being part of the trial, you want to play with this solution and use your own data sets. I will encourage you to do so. And provide feedback, right? We mentioned that the next step of this is to create a configuration-based user interface that we're going to be releasing in beta version very soon. So if you want to be part of that beta program and experience this user interface and how to use that as a vehicle to create machine learning models, please let us know. We're going to start here on the line for a couple of minutes if you have any additional questions. Thank you. Seems that there's an extra question here. Does the neural network use deep learning for the training algorithm?
Yes, I can answer that. So deep learning is one of my favorite terms in industry because it has been so over-marketed that it really doesn't mean anything to most people. And so just to really quickly describe what deep learning is, so you have artificial intelligence, which is either general artificial intelligence or what we call expert systems. Everybody plays in the expert system space. Every solution is designed to do one thing very well, predict one column, play one game, do one particular task very well. Of those expert systems, there are all sorts of different, we'll say, schools of thought. One of them in one subcategory is machine learning, which is a suite of algorithms designed to optimize around data. Of machine learning algorithms, one of them is called neural networks. So this is where you have your linear regression, random forest, XGBoost, and neural networks. And then of neural networks, there are actually shallow neural networks and what we call like multi-layer perceptrons. And then there is deep neural networks, or what is traditionally known as deep learning. So to recognize, deep learning is a subset of a subset of a subset of the artificial intelligence market. And what it means is those neural networks contain multiple hidden layers that try to either build latent states around data or identify correlations and patterns within that data in a very non-linear fashion. And so that is deep learning. And the true advancement in deep learning was using backpropagation optimization, as Carlos mentioned, to effectively train those models to produce very good solutions and answers on a lot of data or time series data. And so yes, Darwin does use those technologies as a component of it in a very dynamic way to try to identify architectures, identify the best way to fit a particular data set. And so as it pertains to, just for another question that came in, will Darwin continuously train and improve itself? So Carlos showed in the example that there is actually a continued training function within Darwin. And so given more data, that function can be called and automated, and that Darwin can not only build the first model, but forever maintain that model given new data and new learnings. So absolutely, Darwin is also designed to not only focus on the model building process, but also the continuous learning, so long as you can set up a process for doing that.
All right. Thank you very much, Keith. I would like to thank everyone who attended this seminar. We are running out of time. We'd like to remind you that we're going to make available all those resources that we discussed here. And definitely, if you have more questions, don't hesitate reaching out to Keith or myself. You're going to have our contact information, questions, how these can come integrated, etc. Please let us know. And finally, I would like to thank everyone for your presence. Thank you.